Welcome to today's Explainer. We're going to dive right in and demystify modern artificial intelligence. But to actually understand it, we're not going to look at some futuristic spaceship. We're going to look back at something super familiar. We're heading to the laundry room. So let's kick things off by challenging all that sci-fi hype you hear on the news. We are constantly bombarded with stories about this magical, impending singularity where intelligent machines wake up and take over. But what if I told you that world-changing shift is actually an event from our past? What if the grand robot future is already an established evolution, sitting right inside your home? Andrew Ng, a brilliant AI professor at Stanford, really hit the nail on the head with this famous quote. He says, "AI is the new electricity." That perfectly frames our whole journey today, because it suggests the future of intelligent machines is absolutely not about a mystical awakening of silicon brains. It's fundamentally an infrastructure project. It's all about engineering, power grids, and distribution.
Section 1. Our first domestic robots.
To wrap our heads around the massive data centers powering AI today, we first have to look at how we mechanized the post-World War II home. It was a steady mechanical climb, you know? Think about it. We went from grueling, back-breaking, all-day manual labor with wooden washboards in the 1800s to the very early electric motors, like the 1908 Thor washer. And fun fact, that thing was incredibly dangerous and pretty prone to electrocuting people. But by the time Bendix introduced automatic washers and dryers in 1937, we had officially moved from horrible chores to essentially owning a programmable domestic robot. You just pushed a button and walked away. But here's the absolute critical part we almost always forget. Those early domestic robots, they were completely useless without a staggering societal scale investment in infrastructure. For your fancy new Bendix washer to even turn on, we needed complex, sprawling plumbing networks and a nationwide power grid to actually electrify our homes. The machine itself was literally just the endpoint of a massive, unseen engineering project. Section 2. Rebranding the algorithm. So, how does this historical hardware evolution mirror the software evolution of modern AI? Well, we've kind of created a false expectation of human-like cognition. Today's AI rhetoric totally pretends that intelligent automation is this distant, magical future that we are waiting to attain. But reality tells a much different story. We aren't building a sci-fi brain. What we're actually looking at are highly advanced statistical algorithms and probabilistic decision-making. UC Berkeley professor Michael I. Jordan points out that this modern rebranding is actually pretty deceptive. Just throwing the label artificial intelligence on it totally obscures a discipline that was steadily built up over decades, using basic statistics, computer science, and control theory. Just take the famous backpropagation algorithm, which everyone hails as the magic core of today's AI revolution. Get this, it actually arose back in the 1950s and 60s in control theory. One of its early applications was optimizing the thrusts of the Apollo spaceships. No way, right? AI isn't some sudden magical birth. It's decades of behind-the-scenes engineering grunt work that was previously used for super practical stuff like document retrieval, telemetry networks, and detecting credit card fraud. Section 3. The hidden infrastructure reality. When you strip away all that mystical veneer, what are you left with? Well, our so-called robot future is actually just heavy industry. Telecom engineer Philippe Enzarghetti really emphasizes this. AI is just the absolute top layer of a massive stack. Infrastructure carries the data. The data enables automation, and that automation is what finally enables AI. Without the underlying stuff, the huge servers, the miles of fiber optics, the physical reality of it all, the AI literally goes nowhere. And this reality has birthed an entirely new job. Just like civil engineers built the bridges of the past, the AI infrastructure engineer is the unseen architect of our current era. They exist in this super narrow space between crazy speed and required stability. They aren't trying to build a human brain in a lab. They're managing vast clusters and disguised supercomputers to make sure the AI economy actually stays running without completely collapsing under the load. Section 4. The trillion-dollar plumbing. Now, to truly grasp the reality of AI, we have to look at the staggering, mind-boggling scale of the physical resources it demands. Remember, this is not just software floating in the ether. This is heavy, physical construction. $500 billion. Let that sink in for a second. That astronomical figure represents the proposed master plan for Project Stargate. This is an initiative just to build the massive independent data centers required to sustain the raw compute power of these large language models. To put that into perspective, down in Abilene, Texas, there were plans to build a single 1.2 gigawatt facility. That is enough power for nearly 1 million homes, and it was planned just to cool the massive racks needed for AI computation. This just proves that the AI revolution is running on finite compute, immense cooling requirements, and vast amounts of physical real estate. Honestly, it's incredibly similar to the massive industrial factories of the 20th century, or the huge grid expansions we needed just to plug in our electric washing machines. It's a massive, ongoing infrastructure engineering project.
Section 5. A new engineering discipline.
Recognizing AI as infrastructure, rather than some kind of magic, completely forces us to change how we govern and build it. Professor Jordan proposes this awesome concept called intelligent infrastructure. It shifts our focus completely away from what he calls intelligence in silicon fantasies. Instead of trying to build a fake human, we need to focus on building robust, planetary-scale systems that actually help us. Because when we project human intent onto code, it leads to really serious conceptual flaws. Like users becoming tragically dependent on chatbots acting as companions. We desperately need an engineering discipline with strict principles of analysis and design to prevent those exact kinds of harms. We're actually already seeing this shift happen in industries like telecom. They're moving away from deterministic, simple rule-based automation and shifting over to probabilistic, AI-driven decision-making. But, and this is a big but, as we build these societal-scale systems, the experts draw a very firm boundary. AI merely recommends, it simulates, and it explains. Humans absolutely must stay in the loop to execute the actual actions. Let me share this quote from Professor Jordan again, because it's absolutely crucial. We have a real opportunity to conceive of something historically new, a human-centric engineering discipline. That is the big takeaway here. We have to tone down the sci-fi hype. We need to stop treating AI as a mystical entity and embrace the serious, real-world engineering challenges ahead. That is the only way we make these systems safe, accountable, and reliable. Just as the washing machine transformed society, not through magic, but through the massive, sweaty rollout of plumbing and electricity, the true revolution of our time is the trillion-dollar plumbing powering the algorithm. History always remembers the flashy discoveries, but the real durability of the AI age, that will belong entirely to its infrastructure. So I'll leave you with this thought to reflect on today. If AI isn't some sci-fi mind, but is actually just the next great public utility, how do we ensure this next generation of domestic robots serves us as safely and reliably as the ones already sitting in our laundry rooms? Thanks so much for joining me for this explainer, and I will see you next time.